Campi Flegrei's ground is rising at record speed. Right now, at this very moment, while you're watching this video, the Campi Flegrei caldera is pushing upward with a force that's been building for 20 years. Every month, another centimeter. Every week, another earthquake swarm. Every day, another measurement that adds to a pattern no one fully understands. The Earth beneath 500,000 people is restless. GPS stations record its every movement with surgical precision. Seismographs capture its every tremor. Gas sensors taste its every breath. Yet for all our technology, for all our monitoring networks, for all our mathematical models, one question remains unanswered. What is this volcanic system preparing to do? The early warning systems work perfectly. The evacuation plans are tested and ready. But the central mystery endures. When does geological unrest become geological action? It started with numbers that didn't lie. On March 13, 2025, a magnitude 4.6 earthquake shook Pozzuoli, the strongest recorded since modern monitoring began in 1970. Windows shattered, walls cracked, church bells rang from the tremor alone. For Dr. Giuseppe De Natale, this wasn't just another earthquake, it was confirmation. Since 2005, the ground at Campi Flegrei has risen 144 centimeters, nearly 5 feet. Not in dramatic upheavals, but millimeter by millimeter. GPS station Wright records every increment, 10 millimeters one month, 30 the next. The February 2025 earthquake swarm provided the clearest evidence yet. Over 600 tremors in days, coinciding with 1 centimeter of uplift. The Italian National Institute of Geophysics and Volcanology moved the alert level to yellow phase 2. Not because an eruption is imminent, but because the pattern they're seeing has happened before. And when it happened before, it changed everything. But that's only part of the story. Beneath the picturesque towns of Pozzuoli and Naples, beneath the ancient Roman amphitheaters and medieval churches, beneath the modern apartment buildings and bustling marketplaces, lies a monster in slow motion. Campi Flegrei isn't a mountain like Vesuvius, its famous neighbor visible across the Bay of Naples. It's something far more complex and potentially more dangerous. A caldera, a collapsed volcanic system 13 kilometers wide that hides most of its structure beneath the surface. Part of it sleeps beneath the Gulf of Pozzuoli, where Roman emperors once built luxurious villas on what they believed was stable ground. The rest cradles communities that have built their lives on top of one of Europe's most closely watched geological time bombs. The caldera's coordinates, 40.83 degrees 14 degree E, mark the center of a volcanic system that has shaped human history for millennia. What's happening now is called bradyseism, from the Greek words for slow and earthquake. It's the gradual rise and fall of ground above an active magma chamber, a phenomenon that operates on timescales that challenge human understanding. Think of it as the Earth's breathing, but each breath takes months or years to complete. Each inhalation lifts the ground. Each exhalation lets it settle. But unlike human breathing, there's no regular rhythm, no predictable pattern. Satellite data from the Italian National Research Council's Institute for the Electromagnetic Sensing of the Environment shows the uplift spreading across the caldera like a slow-motion dome. The deformation follows what scientists call a Mogi model, a mathematical description of how surface ground responds to pressure changes in an underground spherical source. In this case, that source lies approximately 3 kilometers beneath the surface, in a zone where rock begins to behave more like putty under the immense pressures and temperatures. Dr. Christopher Kilburn's recent research published in Nature Communications describes the seismic patterns as burst-like episodes of accelerated activity. Since 2021, these bursts have been getting stronger and more frequent, not louder. The individual earthquakes remain mostly below magnitude 2.5, but the clustering patterns show what Kilburn calls evolving stress states in the rock formations surrounding the magma chamber. The latest data from November 2025 illustrates the persistent nature of this unrest. On November 2nd, 66 earthquakes struck the caldera, ranging from magnitude 0.1 to 2.1. November 6th brought 29 more, all below magnitude 1.1. November 8th, 44 earthquakes. November 9th, 49, with the largest reaching magnitude 2.5. The pattern continues day after day, week after week, with a consistency that both reassures and unsettles the scientific community. The fumaroles, volcanic gas vents that dot the landscape around Solfatara crater, exhale at 97 degrees Celsius, roughly the temperature of boiling water at sea level. The temperature has remained steady for months, showing none of the dramatic increases that often precede volcanic eruptions. Gas composition analyses reveal the standard cocktail of volcanic emissions: water vapor, carbon dioxide, hydrogen sulfide, sulfur dioxide. No unusual chemical signatures, no exotic gases that might indicate fresh magma approaching the surface. Yet the ground continues to rise. The magma chamber, invisible but undeniably present 3 kilometers below, continues to inflate, expanding, pushing everything above it gradually skyward with a force measured not in explosions, but in millimeters per month. Yet what comes next could be even worse. In 1982, Giuseppe Mastrolorenzo was a young researcher fresh from university when the ground beneath Pozzuoli began behaving in ways that terrified even veteran volcanologists. This wasn't the gentle 30 millimeters per month they're documenting now. This was geological violence in slow motion. 100 millimeters monthly, 4 inches of earth lifting skyward with each passing month. Mastrolorenzo documented every day of what became known as the Pozzuoli crisis. His field notebooks, still preserved in the INGV archives, capture the human dimension of geological unrest with scientific precision. Day 47, Signora Benedetti's kitchen floor cracked overnight. Perfect straight line, east to west, following the stress patterns we predicted. Day 73, the harbor is showing bottom. Boats that floated yesterday sit on exposed seafloor today. Day 156, another family packed their belongings. They asked me when they could return. I had no answer. By 1984, the ground had risen 1.8 meters, nearly 6 feet. Entire neighborhoods looked different, with buildings sitting higher relative to street level, with staircases that no longer matched the grade of sidewalks. Families packed belongings they'd never expected to leave behind, loading generations of accumulated life into trucks and cars, while scientists assured them the evacuation was temporary. 40,000 people left Pozzuoli, many never to return to homes that would eventually be demolished for safety reasons. The town's ancient Roman marketplace, the Serapeum, became an inadvertent monument to the power of Bradyseism. Built in the 1st or 2nd century AD, its marble columns bear the scars of past uplift and subsidence episodes like geological tree rings. Dark bands mark the levels where marine mollusks once bored holes during periods when the ground sank below sea level. Light bands show the stone exposed to air and weather when Bradyseism lifted the temple high and dry. Mastrolorenzo remembers the sound of that crisis, not the dramatic rumble of volcanic explosions like Mount St. Helens or Krakatoa, but something more unsettling: the quiet crack of concrete stressed beyond its limits, the subtle groan of buildings adjusting to forces they were never designed to withstand. The earth doesn't roar when it moves this slowly, he would later write in his memoirs. It whispers, and those whispers carry the weight of centuries. Local residents developed their own ways of measuring the crisis. Children used chalk to mark how high their front steps sat relative to the street each morning. Shopkeepers noted how the gaps beneath their doors grew wider each week. Fishermen watched as familiar docking points rose too high for their boats to reach. The entire community became an involuntary network of geological observers, documenting a phenomenon that existed at the intersection of science and daily life. Then, as suddenly as it began, the crisis stopped. The relentless monthly measurements plateaued. The ground stopped rising. The earthquakes diminished to background levels. People returned cautiously, then with growing confidence. Life resumed its rhythm. But the scars remained, Rahanen, both in the marble columns of the Serapeum and in the collective memory of a community that learned to live above geological uncertainty. And now, scientists fear history may be repeating itself. On November 5th and 6th, 2025, civil protection officers led evacuation drills through the narrow medieval streets of Naples and the ancient Roman roads of Pozzuoli. These weren't dramatic emergency exercises with sirens and chaos. but methodical rehearsals conducted with the precision of a symphony orchestra. Buses idled at predetermined pickup points mapped with GPS coordinates. Maritime stations prepared specialized vessels designed for moving elderly residents and hospital patients by sea, should land routes become compromised. The drills revealed the complexity of evacuating a population that has grown around and on top of one of Europe's most monitored volcanoes. 500,000 people live within the immediate danger zone, many in buildings constructed decades before modern seismic codes. The logistics alone stagger the imagination. 2,047 buses would be required for a full evacuation, along with 162 trains and an undetermined number of private vessels. Civil protection planners have mapped 72 separate evacuation routes, each calibrated for different scenarios of road damage or accessibility. Captain Elena Rossini, who coordinated the maritime component of the exercises, described the challenge with professional understatement. "We're preparing for something that might never happen. But if it does happen, we have perhaps hours or days to move more people than live in most entire cities." Her teams practiced loading procedures at 6 different ports, timing each operation with stopwatches while accounting for variables like weather conditions and traffic patterns. The current uplift rate of 10 to 30 millimeters per month sounds almost manageable, until you multiply it by time and consider the underlying geology. 20 years of gradual accumulation have created a landscape that sits nearly 5 feet higher than it did when comprehensive monitoring began. The GPS station right in Pozzuoli records each millimeter with precision that would satisfy a physicist, but the cumulative effect defies easy comprehension. Dr. Francesca Bianco, current director of INGV's Vesuvian Observatory, reviews the data every morning with the methodical attention of a cardiologist reading an EKG. "We're looking for changes in the pattern," she explains, surrounded by monitors displaying seismic waveforms in real time. Not necessarily bigger earthquakes or faster uplift, but changes in the relationship between different types of activity. Her team tracks 17 different parameters simultaneously: seismic frequency and magnitude, ground deformation rates, gas emission compositions, soil temperature gradients, gravitational anomalies, and electromagnetic variations. 6,410 earthquakes have shaken the caldera in 2025 alone, an average of more than 17 per day. Most register below magnitude 2.0, barely perceptible tremors that go unnoticed by residents focused on daily life. But seismologists tracking the patterns see something more concerning than individual events: the mathematical precision of the accumulation. The earthquakes cluster in predictable zones, follow identifiable migration patterns, and correlate with measurable ground deformation in ways that suggest the underlying system is following physical laws that scientists are only beginning to understand. The latest weekly bulletin from INGV's Vesuvian Observatory, issued every Thursday at 2 p.m., reports what has become the standard assessment: stable conditions. No significant changes in gas emissions compared to the previous week. No dramatic spikes in seismic activity. No temperature anomalies in the fumarole fields. No gravitational changes that might indicate subsurface mass redistribution. By every measurable parameter, Campi Flegrei remains predictably active. But stable, in the context of Campi Flegrei, doesn't mean safe. It means predictably unpredictable. It means the volcanic system is behaving consistently within its current pattern of unrest. But that pattern itself exists far outside the range of normal geological background activity. Dr. Bianco chooses her words carefully when discussing the weekly reports. Stable does not mean inactive. It means we understand what the volcano is currently doing, even if we don't know what it will do next. Because what happens next could rewrite maps. Dr. Francesca Bianco stands before a wall of monitors in the Vesuvian Observatory's control room, each screen displaying a different aspect of Campi Flegrei's vital signs. Seismic waveforms scroll past like geological electrocardiograms. GPS displacement vectors update every few hours. Gas chromatography results arrive via satellite link from automated stations scattered across the caldera. She chooses her words carefully when discussing the volcano's future, speaking with the precision that comes from 3 decades of studying systems that operate on timescales measured in centuries. "We are not in a pre-eruptive phase," she states during a recent press conference, each word carefully measured. "But we are in a phase of unrest that requires continuous attention." The distinction matters more than most people realize. Pre-eruptive suggests imminent danger, emergency protocols, mandatory evacuations. Unrest suggests something more maddening for both scientists and the public: indefinite vigilance without clear resolution. The volcanic system that created this caldera operates on timescales that dwarf human planning capabilities. The catastrophic eruptions that formed Campi Flegrei occurred 39,000 and 15,000 years ago. Events so massive, they affected global climate patterns and left geological evidence across Europe. The Campanian ignimbrite eruption, the larger of the two, ejected an estimated 300 cubic kilometers of material into the atmosphere, creating the caldera structure that exists today. For perspective, that's roughly 6 times the volume of material ejected by Mount Tambora in 1815, the eruption that caused the year without a summer across much of the northern hemisphere. Current satellite models based on data from the European Space Agency's Sentinel-1 constellation predict continued uplift at current rates for the foreseeable future. The interferometric synthetic aperture radar, INSAR measurements, show the deformation field extending well beyond the caldera rim, affecting an area of approximately 200 square kilometers. The pattern resembles what geologists call a resurgent dome, the surface expression of magma chamber expansion, that may continue for decades without necessarily leading to eruption. Geochemical monitoring stations positioned at 12 locations across the caldera analyze gas compositions every 6 hours, searching for changes that might indicate fresh magma approaching the surface. The ratios remain stubbornly consistent: 95% water vapor, 3% carbon dioxide, 1.5% hydrogen sulfide, and trace amounts of sulfur dioxide, helium, and various noble gases. Dr. Alessandro Ayupa, who leads the geochemical monitoring program, describes the stability as both reassuring and puzzling. The gas signatures suggest a deep magmatic source that isn't evolving rapidly toward eruption, but the ground deformation tells us something is clearly changing at depth. The most likely scenario, according to current data and historical precedent, mirrors the 1980s crisis: gradual escalation followed by eventual stabilization. Mathematical models suggest the current episode could continue for several more years before the underlying pressure balances reach a new equilibrium. The ground will rise until it doesn't. The earthquakes will continue until they stop. But the timeline remains frustratingly uncertain. Yet Campi Flegrei has erupted as recently as 1538, creating Monte Nuovo, New Mountain, in a matter of days. That eruption, well documented by Renaissance scholars, began with only a few days of felt earthquakes before explosions created a new volcanic cone 123 meters high. The eruption lasted 8 days, displaced thousands of residents, and fundamentally altered the local geography. Importantly, it occurred without the sophisticated monitoring networks that watch every breath of the caldera today. Contemporary accounts describe the 1538 eruption's onset with remarkable precision for the era. Antonio Marchesini, a local merchant, wrote, "On September 27th, the earthquakes began in earnest, such that no man could stand. On September 29th, the ground split open and fire emerged with such violence that stones were thrown higher than the flight of birds." Modern analysis of the geological record suggests the total precursor period lasted perhaps 48 hours, far shorter than the 20-year unrest episode currently underway. Professor Giuseppe Mastrolorenzo, now in his 70s and still active in Campi Flegrei research, offers a perspective shaped by decades of watching the volcano's moods. "We know more now than we've ever known about what this system is doing. We can measure its every tremor, track its every movement, analyze its every exhalation. But knowledge and prediction are different things. The volcano will decide its own timeline, and our job is to be ready for whatever that timeline brings." The early warning systems function with unprecedented sophistication. The evacuation plans exist in multiple versions for different scenarios. The monitoring network captures every geological whisper with precision that would have seemed magical to previous generations of scientists. Yet the central question remains stubbornly unanswered. When does geological unrest become geological action? When does Bradyseism become eruption? When does monitoring become emergency? For the 500,000 people living above this slowly inflating magma chamber, daily life continues with a peculiar form of cognitive dissonance. Children walk to schools built on ground that rises measurably each month. Families plan vacations while civil protection authorities practice evacuation procedures. Restaurants serve dinner while seismographs record the day's earthquake count. It's a form of coexistence that exists nowhere else on Earth, living normally atop one of the planet's most closely watched geological systems. Stay safe, stay informed, and remember that the Earth beneath our feet tells stories measured not in human lifetimes, but in geological epochs.